Okay, so I suppose if you're watching this video, that's great because it's telling me that, hey, you really enjoy math and you want to see the reasoning behind why we're able to have something. And so what I'm going to do, I'm going to just basically go over the proof. In order to do the proof of this, we're actually going to use the law of cosines. All right, so basically, make sure that I have enough room for everything. If I do the law of cosines, we have a triangle. And I'm going to try to make it very similar to what we have to the right. And so we'll go ahead and label this side, we'll say that's B, I'll make that lowercase b. I'll denote that as, no, not yet. So that's B, that is going to be A, and say this is C. All right. And what we want to find is this angle right there. All right. And so we could call this capital C, capital A, capital B. All right. So if we're, back in a trig class and we're using law of sines to find, angle theta, what we can do is we can use the law of cosines to find that theta. And so the law of cosines says is that I can take c squared, and that's going to be equal to a squared plus b squared minus 2 times ab cosine of theta. All right. And that will allow me, if I know what A, B, and C are, if I know the distances of those sides, then I'm able to find the angle that's in between sides A and B. All right. Now, what I'm going to do is I'm going to express this same type of picture, but as a vector. All right. And so, say we have vector B. Say we have vector A, and we have the distance between those two vectors. Now, if you remember from last class when we were talking about adding and subtracting vectors, we know that this vector that I just created, that matches the two endpoints of vector B and vector A, is really, or the terminal points, is A minus B. Right? And you'll see that, hey, this is very similar to what we have over here. All right. And let's go ahead and put this angle there, theta. And so what we're going to do is we're going to use the law of cosines, and we're going to write out our formula over here for what's in red. And so to find that angle theta, what we can do is we can take c squared. Now notice c and a minus b, they're corresponding. C is the distance of a to b. So the vector a minus b doesn't represent the distance. What represents the distance of a minus b would be the vector. I'm sorry, not the vector, but would be the magnitude or the distance of a minus b. And so we want to square that. So we have a minus vector a, let me denote those this way. So we have vector a minus vector b. We have the distance of that squared. That gives us the length for this side of our triangle. That's equal to, now a is corresponding to vector a, so therefore if I want to find the length of that side, it's going to be just the distance of vector a. And we're going to square it like we are in the formula for law of cosines. Same thing for b. And then minus 2 times a, the length of a, so again, the magnitude A and the magnitude of vector B times cosine theta. And so now we've used the law of cosines. Now, if you remember, up from above, the distance of vector A minus B squared is just the dot product of itself. So the dot product of vector A minus B is the same thing as the distance of vector A minus vector B squared. So that's the left side of the equation, all right? On the right side of the equation, all right, we have vector A squared. So what do we know that to be? It's just A, I'll leave the other side alone for right now. I'll get back to that. So in order to do the dot product between two vectors that we're taking the difference of, it's very similar to just FOILing. And so, when you actually will do the dot product of all these vectors, what we'll get is we'll get A vector A dot product of vector A. We'll have, minus the dot product of vector A and vector B, but we'll have that twice, so it'll be minus 2 vector A dot vector B, and then plus, because there's two negatives, B dot B equals to all the stuff on the right side. Now, what we're going to do is we're going to go ahead and combine everything that we have. And so, I know what A dot A is. A dot A is just the magnitude of vector A squared minus, I'll go ahead and keep that to A vector times B vector. No, not dot. Plus the magnitude of B squared. And that's equal to, now I'm going to write all the stuff on the right hand side. Vector A squared plus vector B squared minus 2 times vector A times vector B cosine theta. And then hopefully now you see, some things are going to cancel out. I can bring on the right, the distance of vector A squareds are going to cancel out. Then we have, the magnitude of B squared, they're going to cancel out. And then we're also able to divide. Well, here, I'm going to just write it out. So we'll have negative 2 A vector dot B vector is equal to now just negative 2 vector A, the magnitude of vector A times the magnitude of vector B cosine theta. We're able to get rid of the negatives on both sides, and so now we have proven that the dot product of A and B is equal to the magnitude of A times the magnitude of V cosine theta. So hopefully you enjoyed that. If not, you probably didn't watch it. So that's just, a proof